All right. So first of all, I would like to thank all the 5 keynote speakers for giving us such an exciting set of talks throughout the day. And let's thank all the speakers as part of the starting part of the panel. So as you can see, the keynote speeches that we had throughout the day, basically they cover a pretty diverse collection of topics, focusing on the IoT context, ranging from the healthcare systems, like the sensing solutions in the developing countries, all the way to the robotics, large language model serving their AR, VR systems, and the privacy in the AI systems. So with that being said, as the last part of the IoT program, I would like to raise a specific topic, like generally related to all the speeches. That is how we gonna be what's our vision and what's our thoughts about the interaction between the physical, I call it physical, but basically that's like a sensor and actuator systems, which are more like the traditional definition of Internet of Things, right? So as all of us know, basically the Internet of Things basically is a more modernized name of sensor networks. That's its earliest definition. And then later on, there are all kinds of like a modernization of the names, including like cyber-physical systems, like the Internet of Things, and then people call it like AIoT, artificial intelligence of things, and like that, right? So I would like to use the conventions of the names in the cyber-physical systems, right? So this has been a common term, and mostly it includes the cyber part and the physical part. Physical part basically means the physical hardware, including the sensors, actuators, and also the communication systems connecting that part, right? That two parts. And the cyber part, basically that means the software system. But over here, I rephrase it to be like just the AI part, including the models, including the architecture, including the data-driven methods. So as you can see, basically in the past few years, with the fast evolvement of the AI models and their penetration of the AI capabilities, this has been largely changed how the IoT systems has been evolving, has been operating, has been thinking about, right? So in this panel, we would like to hear all the panelists' opinions, the visions and thoughts about how we envision these two aspects going to be meeting each other, going to be intersect with each other right now and in the near future, and how all this brings us new opportunities, new challenges that we as the system researchers could embrace, could make contributions. So with that being said, we basically have made this list of questions. And as you can see, this basically covers starting from the killer applications in a domain, and we cover from both ends, right? On one end, how do we think the current AI methods and techniques has been good enough to embrace the physical systems? And vice versa, how do you think the physical systems going to be good enough, or whether they're good enough to fully unleash the power of the AI, right? Then we're going to go through further regarding like the vision of the world models and AGI, and also the workforce training and the education. So what I will be doing is that let's go through the list of the questions, and we're going to divide the panel into a few like small segments, and in each segment we're going to focus our discussion on one of these questions, and we welcome each of the panelists to just like it's more like an open-ended discussion. So we welcome all the panelists to share with us your opinions, your vision from any aspects, right? Both the academia, the industry, about focusing on this topic. And we also welcome, after we hear about the panelists, we also welcome the open-ended discussion from audience. So any of you guys can, stand up, come to the microphone, ask questions to the panelists, or even just share your own opinions about that and foster some further discussions. And we're going to probably spend a few minutes on each of these questions, then we move to the next. Okay. All right. So let's get started. So the first question I will be asking is that, so with the fast evolvement of the AI capabilities and the penetration of the AI models, what do you believe to be the killer applications in the IoT domain? Especially, IoT, this concept has been there, right, for many years, like from the central networks to cyber-physical systems to what we call the Internet of Things nowadays, right? But there has not been that many killer applications becoming in the reality, in the industry products, right, compared to other domains, for example, like mobile computing, for example, for like wearable computing, for example, right? So the question is that right now we have a very powerful tools of generative AI, and in the future, we'll be foreseeing that even powerful AI tools being developed. So with such enabling technologies, what do you foresee to be the killer applications that has been emerging or probably will be emerging in the future that can drive even more values and merits of the Internet of Things? So, please.
Can I just start? Maybe
Yeah, please.
Maybe give everybody time to think about it. So I think, so I'm going to only talk about healthcare, especially biological systems. So biological systems are really complex. So like human biology, for that matter, other biologies are very complex. For large part, we actually don't understand bulk of human biology, especially when it is in a disease state, when something goes wrong and what happens, right? And we also don't have much mechanistic understanding in many cases. Mechanistic understanding of what causes A to happen and then B to happen and so on and so forth. So here are three systems which are actually deployed today. Pacemakers, right? Pacemaker is actually a system which is installed. It is trying to make sure that the heart beats correctly. It's actually a fully electronic system, if you think about it. It's batteries in it. It has to study materials and so on and so forth. There is neural implants called deep brain stimulation. It's a FDA-approved intervention for people with severe Parkinson. If you see people with very shaky hands and DBS is installed, and you can see suddenly they will have no tremors, right? So it's actually remarkably good for some people. And now there is artificial kidneys for people with type 1 disease. It does insulin control inside the body. It's a closed loop system, right? So they're actually trying to mimic kidneys in that case, or what kidney function is. So the reason I'm mentioning these examples is this is already happening. These are all FDA-approved strategies. Millions of people use it already, so on and so forth. I think currently there is zero sharing of knowledge from one system to another. Okay, so let me use the DBS as an example. Brain is so complex, we actually don't understand most of the brain, by the way. And everybody's brain is wired differently. So I think it would be a cool thing to think about, and something we think about with our collaborators, is that if I have a system installed and I'm learning from somebody's brain, because many of them also have sensors and not just actuators, then this data, won't it be nice if we can actually bring it out from every DBS installed in, or embedded into some other people's brain, and then learn what we are learning from each other, and then share this understanding that this particular form of signaling was useful for this person in this state, maybe it's also useful for this person, right? So this currently is a lot of time done by DBS for DBS patient. Actually, the changes are done by doctors one step at a time. And essentially, they are missing out on the strategies what other people are developing. So, so what would be nice in healthcare setting to learn from other people's use cases and then benefit anybody who has done it. And all the strategies which were probably said in robotic systems, and they can be programmable, they can learn from each other, so on and so forth, could eventually be implied. They're all robotic systems, very simple versions of it, if you want to call it that. That collaborative learning doesn't happen in healthcare today, across devices. So I'm only talking about IoT, like across devices. I think we are probably missing out a huge piece of knowledge in not doing so. One of the biggest threat which I think the MobiSys community is the security, changing something's operation, either through software or through something beamed into it without human intervention or observation, is a massive risk. And I think currently nobody's willing to take that risk. Right? So yes, my pacemaker could operate better, but it's operating. My heart is beating. I really don't want a way to send a program to it to change its operation that could probably be a security hole, which then eventually could kill someone, right? So that, I think the bar for security safety has to rise so high. But if we can meet that bar, then collaborative learning could truly change the way embedded devices in bodies happen. And I think there'll be more of them, because there's some certain biologies which are so complex, people are actually not using them right now because they feel like they cannot do a good job at it. So I'll stop here.
I'm probably slightly biased as I work in reality lab research, but I think wearable AI, as in having a companion AI assistant that is always on and are in conjunction with the wearable devices, is what I see as a killer application. When you need an AI agent that understand your 3D environments, your interaction with them, and leverage these holistic picture of what you're doing in the real world to your assistant, whatever your end goal might be. Actually, to the discussion just happened, I think a lot of the scenarios I talk about may not be mission critical. For example, if you want to make a recipe for smoothies, it's not that big of a deal if the smoothie that the assistant recommended is not in particular the way you want it to be. However, I was kind of curious, as in the other panelist was talking about like a pacemaker for your heart, right? This is like a completely different bar. This is definitely not my expertise area, but I was curious if people have thoughts about how do we make AI so secure and consistent that hallucination is just not really a problem for things like that are going to be mission critical, because we're talking about a life and death here.
I like that you're talking about like this assistant idea, because for us, for my context that I'm in, it's what I see is the same thing, but it's a lot more scoped down. We're just trying to help like ministries of health in these countries in Africa repair their equipment, right? They have staff turnover problems, they have lack of resources. So if you give them IoT data, this is working, this isn't working, here it is, and you encapsulate just enough knowledge about, well, this is how this piece of equipment works, here's the spare parts you can use to try to replace it, you can take someone that's relatively unskilled and help them sort of upskill and learn and know and actually solve these problems and repair this equipment. So, like an assistant, on-the-job training and those things. And that's really what I see at least for my little corner of the world, what I see the killer app as, is just like being able to take advantage of or make use of even less resources and less knowledge and skill and training. In the space we work in, training's a multi-billion-dollar industry, and 20 or 30% of that is spent on travel and all those things. And suddenly you could really reduce that and save that money and move it towards other important things. So.
The question is about killer applications, right? Right. So I think maybe it's a red herring to look for killer application. I don't believe there will be something like smartphone. Smartphone showed up in mobile computing. That's a killer application, right? But I think IoT, the domain, is fundamentally different from the mobile computing scenario. I think it's more fragmented. There will be a lot of corner cases, but in totality, it will be as significant as smartphone. But there will be a lot of small applications that we don't even pay attention to, right? For example, home automation, maybe it's a few $1 billion, maybe pacemaker, right? There's another. So I think there will be a lot of application, but there's perhaps no single one that will be the killer application. That's my thought.
Yeah, I sort of thought about it the same way that Lynn did, which is in terms of scale. Like, I think for something to be a killer application, it has to reach like ludicrous scale, like the smartphone or the PC did. And I have a hard time thinking of IoT, like a consumer-facing IoT product that could reach that kind of scale, but I do think that there are sensing use cases that can get to that scale. The first would be autonomous vehicles. I don't think I'm going to say anything that people surprised by. But I think autonomous transportation, I think as the charts I showed demonstrate, like it's already taking off. Like I'm kind of blown away that Waymo is already bigger than Lyft in San Francisco. That's amazing to me. And from everything that I can tell anecdotally, it's a great experience. I know they're already expanding rapidly. You know, within our lab, we recently had someone get a Tesla, for those of you who know Sharad, and he says, yeah, FSD on his Tesla is amazing. He actually took me for a test drive to get lunch up the road. He took his hands, he hovered his hands over the wheel, and it got us there. And this was, you know, maybe 6 or 7 months ago. And, you know, this was on the old hardware with the old models. So to me, it just seems obvious that autonomous transportation is going to take off in the next 5 years. And just beyond passenger transportation, you know, there's logistics, there's like all these domains in which moving physical objects from one place to another on roads or through the air, I think it's just obvious that's going to happen. And then a little further down the road, I do think domestic robotics will take off. I think that's going to take us a while, as I kind of alluded to in our talk, but I think that will achieve smartphone level scale also.
Yeah, I totally agree. Actually, I talked to my daughter saying that within the next 5 years, we're going to see like a humanoid robots to be like a daily instrument that in everybody's home, and we can use robot to cook dishes for us, wash clothes, and do everything. I don't know whether that's going to be the truth, but so I totally agree with what being said. And also, we would like this panel to be as interactive as possible, so not just between me and the panelists. So for the audience, like if you have anything to say, like want to ask a question, want to share your thoughts, you know, just feel free to like come to the microphone and speak up. Okay. All right. So with that being said, for the sake of time, I will be moving to the next question. And with that one, I'm going to be basically put 2 questions in the batch. So we are talking about like the cyber part and the physical part, right? So the physical system, sensor and actuators, and also the AI methods. So the question is whether right now, for these 2 aspects, do we believe that they have been fully developed? Do we believe that they have been already good enough? Or if one aspect has not been good enough to match the other aspect, what do we think are still missing, right? And one step further, so as system researchers, like the mobile system community that we are talking about, what we can do to help bridge this gap, either from their like the physical system, how do we think, or how do the panelists think we can develop better sensors and actuators that can, if the AI model saying that, okay, we should do this, we should do that, whether the actuators will be actually good enough to do such things, right? And from the AI models perspectives, if we want the models to be like intelligent enough to make like human-like decisions or perception, are they able to do that right now? And if not, then what are missing and what we can do to further push the limit forward?
I'll start and then let other people take a moment. And am I amazed by the AI development over the last few years? Absolutely. Doesn't mean they're perfect, you know, or good enough. I think good enough is really defined by your application. You know, if you to ask, is there more to be desired? Absolutely. For example, just take the always-on AI assistant, for example. Most of the devices that can do it today will require going to the cloud, you know, get your answer from your queries, your prompt, whatever, and then come back in a round trip. So that round trip is going to take time. If you want something like a super low latency applications, that means, you know, important time that make your application less compelling. So, you know, model compression is definitely a very important topic. I'm sure, you know, people here can have, you know, better expertise than me about, for example, how to make the hardware better, how to accelerate AI models, and how to even make, you know, AI models smaller during binarization, other quantization, other techniques. So I'm now going to go super deep there. What else? Yeah, I mean, for example, how can we, you know, like we talk about, like a pacemaker just now, right? How can we make them more explainable? How can we make them, trust them essentially in this like, mission critical cases? Again, I'm not an expert there, but I believe, I don't think people are kind of ready to deploy them into pacemakers as we speak right now. Or should we? Another question. So these are the things that worth looking into.
I'll go next. So I kind of came at this question after working with some of our robotics people, in particular people who are building foundation models for robotics. And the work they're doing, so one of the models they built recently is called Magma, and there's others like OpenVLA, but these models are really impressive, but they're not all the way there. And so number one, so what these models generally do is you can describe a task, and then they can output commands for a robotic arm or hand to achieve that task. So the one that keeps coming up in the demos is like, pick up a hot dog and put it in a bun. Okay, so you can do that. They can do that, and does that very well, right? But part of the problem is, and they're open about this, is that if you change the setting, if the camera changes, if the shadowing changes, if the hand changes, if the objects change or the angle, then the model does quite poorly. And you have to fine-tune, refine-tune for any particular setting in which you are deploying it. So in that sense, that feels like something that a systems person might be able to help with, in the sense that if you have a setting and you can observe you can recreate the camera angle and you can kind of observe the correct behavior that you want, then you can train and create this fine-tuned version of the model so that when you deploy the arm or the robot there, then it's already got its fine-tuned model. It can work right away. So that seemed fine. The other part of this question asking about like whether the actuators are fine enough, or the sensors. My sense is that you don't want the model to have to worry about that. You want the model to generate very coarse instructions, like move this joint in this way, rather than worrying about the specifics of the hardware. And you have drivers to sort of translate these high-level things into low-level actuation and sensing. And I think that's probably the right approach. But that was the other part of my reaction to the question.
So I'm going to make two controversial points. Right. One is, I think, read to what Landon said. I think the success of large language model made it appear that AI is easy. But we're just lucky because language is such a highly structured artificial being. It's so simple compared to sensor data, compared to image pictures. So that we have working, powerful large language model that writing code, speaking human, having conversation. That's just we're lucky because of language. I think beyond the language, vision, sensor, anything, that's, I think, what our models. I don't think we're there, like Landon pointed out. The discrepancy between test time data versus training time data just kill. Right? Computer vision, people believe like YOLO is done. It's already the best object recognition. But if you talk to people in Motorola Solutions who do surveillance cameras, they would tell you this model wouldn't work because they're not trained on low lighting, slowing, raining, dust cover the lens. So I think there's a long way to go for any model that go beyond the language. I think we're not that lucky. We have not yet found the final solution. I think a lot of work to do. Okay, now my second, maybe more controversial point is we asked for like hardware versus software model with AI versus hardware. Let me see, it is always hardware is the limit, is the problem. It is always the hardware. Think of a pacemaker. It's basically the battery is the problem, right? But many years ago, they used a tiny nuclear reactor, put in a pacemaker, because that's before lithium-ion battery. With lithium-ion battery, they got rid of the nuclear reactors, but there's some dead people who send the cremation, they have to be careful they don't burn it. But So now you know, right? Electric cars is because battery, right? Now look to robots, like since I work on robot dogs, I was surprised to learn it's a motor, that's the limit. Anything in software that you can program to software, it's easy. You can always use a cloud, thanks to Microsoft, right? It's a hardware, that's the thing, you cannot offload, there's no Moore's law, there's no exponential growth. That's always going to be a limit. I think in general, I believe hardware is going to be bottleneck in many application cases.
I'll keep mine very short. Maybe it's because I have a very focused job and a very focused purpose at my company, but I mean, I feel it's there. Like the IoT data we generate is just temperature, or just like, is this thing running? Is it working or not? It's simple enough. You know, I worry a little bit about data quality, gaps in data and stuff like that, but you know, for the AI to understand this, spot trends, do that basic, like, here's what you need to do, and taking that information about, you know, what we're trying to accomplish, like, I think it's there. And so I think the quality of the data that our, you know, our physical systems, our sensors are generating is good enough. So, but I get the point that for other things, it's very far away, so.
I generally am object to the use of word AI everywhere. So that's all. I have the worst conversations, the most difficult conversations. Yeah, I have no idea. I think there should be artificial intelligence and artificial stupidity too, because it's, I think, yeah, we are actually, so I mean, all the work I have seen, the systems are actually really good at being very good at what humans are already good at, especially if you around language, but they're actually confused. Their confusion looks exactly like human confusion. That's what they've learned from. So, but I think we unfortunately right now also have to deal with what I call stupidity, because I talk to folks and they say, won't AI solve this? I said, if I don't want to have a conversation with them, I'll say, yes, it will solve it, and I'll leave. But if I want to have a conversation, that will last days, right? So mostly because I think this AI, even linear regression is AI these days. So I'm really tired of it, by the way. So we should have a little bit more technical, in-depth conversation in a MobiSys, I think. So what is AI, by the way? I have no idea. What is the definition? Does anyone have a definition? Or what's not AI? Maybe that's the question.
I think in this context, probably anything about the neural model.
There has been research talking about, I think people are talking about neuromorphic computing, for example, and when like Godfellow and Jordan, they first developed the concept of neural networks, their intent is to like mimic how the human brain works, right? That's actually, if you backtrack to the very beginning, that's all their design intent of the like neural networks. That's why they call it the neural networks, right? But I completely with you, Ashu. I think there's still a long way to go to make AI like really to be intelligence, right? So, for example, like one of the recent things that I saw from like Fei Li from Stanford, and she actually has a vision saying, right now when we're talking about large language models, we're talking about like language intelligence. We can produce languages, we can produce text responses, right? But that's only part of the human intelligence. And there is one part missing, for example, is like a space intelligence, for example. Like we can perceive things. I know that how far that chair is away from me. I can use my experience to estimate, right? But if you ask the language model to do such thing, even for the simplest task, they will just like fail. And this is something that people are missing, and they are challenging basically whether transformer, for example, is the right solution, or we need another like fundamentally new architecture. I think that's definitely something that still missing right now. And regarding Lin's comment on the hardware, I very much like your vision on that, and I believe in particular you are talking about like those sensor and actuators, right, instead of the computing hardware, right? Because for computing, it's like we have a GPU, and it's just like another Moore's law, and they are reaching the end. There is another scaling law of the computing power. That has been well studied. But regarding the sensors and actuators, right, I think this is actually interesting and unexplored area. And my follow-up question is that, like, for example, when we migrate from CPU to GPU, that's actually a big leap, because the computing, the way they compute is like totally different. And the people discover that the high level of parallelism is something that can drive the AI forward, right? But if we look at the design of the sensors and actuators, probably over the past like decade, for example, they have engineering innovations, but if you look at the fundamental way how it works, right, still that's pretty much the same, right? We have like a small tweaks, but like how the robot like behave, right? The robot arms, they are still being driven by the step motors. Step motor has been there for like, I don't know how many years, but a long time ago, right? So, oh, okay.
Hello, my name is Federico. I'm from the University of Illinois, and I just wanted to kind of take this perspective of, I understand that a lot of these discussions are about what are the new capabilities that AI can give us in the systems that we build. But I was wondering from your perspectives, have there been approaches that may have failed or not performed as well by adding these AI features to technologies? I'm kind of taking devil's advocate here, right?
We did an experiment late last year where we had the IoT data, so like metrics around performance of vaccine refrigerators like on the dashboard, and we're like, hey, get a set of biomed technicians and be like, ask it some questions. What do you want to know? And it just didn't compute. It was just like, they typed in a few words and the AI obviously couldn't figure out what they were asking. They weren't even sure what they were asking. So it's like this is potentially just a UI, UX problem, right? And just like helping them understand and what's possible and what the potential is. But and I wouldn't count it as a failure, but as in terms of an experiment, it's interesting to see that different people have different expectations for what they want and how they might interact with the systems.
Actually, I'm going to follow up. This is a great example. And in healthcare, that's a really crucial thing. So Epic, for example, which is a system used by 70% of the hospitals, also has an app called MyChart. Maybe many of you have it on your phones. In MyChart, there are many functions. You can get your test results and so on and so forth. There is a chat feature. You can actually talk to someone at the other end, a human often. What they do want to do is, most hospitals want to actually make the chat feature more interactive, like more supportive, and allow people to resolve some of their issues upfront. And there's a very concrete example. So this is actually a significant problem. I go to the doctor, they tell me, explain what my condition is, they give me some medication, they say, take this medication after eating something, and these instructions will actually be written somewhere, yet you find many people have difficult time adhering to what was told. And then they have questions. And their questions are often get unresolved. They don't ask follow-up questions. What happens is people just don't take the medication. So this is actually very common things, right? So what they want is people to just talk to someone on the app. So the thing which is what doctors or any trained person is very, very good at is to taking extremely ill-posed queries and figure out what they're asking. Humans are exceptionally good at it, especially if they have the context, right? So if you think about parents are so good at figuring out what their kids want after a while, but the kids have almost no language capabilities when they are 1.5 or 2. But the parents can figure out, I think that's what they need, right? This is, I think, an amazing skill humans develop from context. And there are many things involved in it. Sensors are involved in it, other understanding how kids behave, and so on and so forth, right? Same applies to the healthcare example. This is what I think folks are still struggling while you don't see any of those chatbots deployed yet, is that you get ill-posed queries which might be mixing up multiple topics into one question. How do I figure this out? How do I parse it out and answer the question which they might be answered? And that, I think, we have some ways to go. I would call that a failed example. That's why it doesn't exist today.
That's great. It reminds me of the example, I don't know if this is real or not, but the person who had a conversation with the AI for a car dealership and got a car for $1. It's a great example. Well, thank you for sharing.
I'm Winnie, and I'm a computer science professor with Cal State Fullerton. So, because I'm nearby, so I drove by to see. And good to hear all of the very cool tech innovation and the wearable AIs and AIM. But what I am more interested is the AI education, especially for our next generation of younger kids. Because I'm gonna run a pilot summer camp program. So we partner with the center to pilot a summer camp for AI education for K-12 students. So my question is, it is the right time to start with this type of program? And so how should we educate our students? Because for K-12 students as well as college students. Because now, like in computer science, coding is so easy. So should we teach our students to, okay, you just use AI and generate code? And should we still just follow our traditional way to teach like data structure, algorithms, Python, C++? Thank you.
Well, this is actually, I also have this question listed on my list, and we would like to just jump to the last question. So this has actually become a big problem, right? I know my TA is using AI to do the grading jobs. They just type the answers to ChatGPT and ask ChatGPT to do the grading work, right? And I mean, AI can write better programs than humans nowadays. So the question is that how do you think this will affect our ways of workforce training and education, right? It's not just within classroom, right? It's also like including general training. And how do you think this will affect computer science, right? Not only computer science, but also
not only computer science, the college students and also the K-12 students. So should they still learn English and math and history?
Yeah, and also what changes do you think we need to make, not only within classroom, but also generally in both academia and industry to embrace these challenges?
And I think there are folks in the audience who are from industry, so I hope they can comment too. But this is just a fresh conversation I just had yesterday. So I have a good friend who is the CEO of a big company, KGM, which supplies software to hedge funds. So for example, and so they have around 1,000 employees, 850 of them are programmers essentially, right? And they have actually deployed all sorts of programming assistant systems and studied what happens to their employees. And what they found out is people who are already very good at it just become better at it. Like their productivity shoots up. People who are not good at it, they just become worse at it. So in his mind, the difference is actually even further increased, is amplified. So if I were to take whatever from that one data point, one company, around 850 employees, so it's not a small number. Sorry, 10, yeah. And then if I work backwards from it, what should I do as a professor? I think the basics are important. They need to learn basics. Now, whether those basics will change a little bit, I think that is up for debate, and we should all discuss it and learn from each other. But I just cannot see how they can be successful in the job if they don't understand fundamentally what programming means, what all that things are, versus just generating a code, right? And I think that logic is a very important part of all this stuff, right? So I feel like if they have to understand it well, and additionally communications, I can show you an email which my wife got. She's also a professor today. This is clearly AI generated email. And she had to share with me, and I will share with you, all of you later, but I think the point here is she feels sorry for the student who's struggling and tried using AI to get better. She only got poor outcomes out of it, right? And the people who are good are just getting better at it. So it's actually creating an inequity in different ways. Not the way we wanted it to, but that's actually happening right now. So I think fundamentals are really important. We simply cannot ignore it.
Yeah, I actually completely agree. I think it's terrible for teaching and learning. I'm going to take an extreme point on this, but yeah, I don't think you can learn without deep concentration and struggle. I think that's really essential, and I think AI is just too tempting to almost everybody to take shortcuts. And yeah, you can be more productive. So I understand why companies embrace it, it makes their employees more productive. But I think that's a different question than should it be used in education and pedagogy. I would keep kids away from it as far as you can. I just don't think that it's a good substitute for struggle and deep concentration. And once you've gone through all that and you've learned things, you learn the basics, then I think it's a superpower. I mean, I've experienced this, but that's after decades of experience. Like if I just sort of had this from day one, I don't think I would have learned anything. I was telling somebody recently, like I've written probably tens of thousands of lines of code in Go and Python the last 4 years. I still don't know those languages as well as C, because I didn't have AI assisting me when I was writing my C code. But because almost all of my Python and Go code is AI assisted, my productivity has gone through the roof, but I don't know those languages nearly as well. I know this myself in my soul. So yeah, I think it's very bad for learning. Just my 2 cents.
Maybe I want to add to that. If we take a long view of computer science curriculum, 50 years ago, assembly programming, and then hardware design was a significant part of computer science curriculum. Today, computer science major only get a little bit exposure to assembly language in one of the introductory courses, and that's it, right? Maybe zero hardware design course, maybe only a little bit introduction. So my point I'm trying to make is, if you take this view, you will see computer science as the evolving discipline. There's certain things we take for granted as fundamental may become peripheral. Operating system, for example. Why do people have to learn how op kernel works? Right? I do operating system research. I'm shooting myself to say, hey, maybe one day operating system should not be required, should be elective. Right? So I think that's my first point. Number two, I think our lifespan is limited, and the number of years we spend in school is also limited. We cannot teach everything, and with a lot of new things come in, we have to get rid of old things. But what to get rid of, I don't know, right? But I think it's at this point, I think it's the entire we in academia and also people in industry are trying to figure out what's the impact of generative AI. I think it's just maybe need time to take care of it, and people will figure out, right? I think I'm optimistic. AI is just a tool. With tool, people found a powerful way to improve their productivity, create equity issue, like Ashu pointed out. But that's just an opportunity for us to think about how should we teach students how to use this tool for their productivity. Right? I don't have the answer, but I think I'm optimistic.
I'll be really fast, and sorry, I'm going to be kind of, I don't know, flippant is the right word. But first I'll say that within my company, we have 7 engineers, and they're all saying they're getting at least a 30% productivity boost, if not more. But they're all skilled engineers. So the flippant part, I've heard some schools have stopped teaching cursive. Like, there's children out there that don't know how to read and write cursive handwriting, which is fascinating to me. And then 2 quotes, and I don't have the attribution to these. You won't lose your job to AI, you'll lose your job to someone that knows how to use AI very well. Then the nicer one is, whether you like it or not, your job is changing. We can work to make use of these tools so we can work on more interesting problems. And then a quick anecdote, we recently were hiring, and we reduced the 400, 500 applicants we got to about 30, and maybe about 4 of those were not at all who they claimed to be and who their resumes claimed to be, and did not have the experience they claimed to have. It took a little effort to figure that out, but it was wild. Just an example of where AI can be a little bit destructive and misleading.
I don't think you're answering your question.
Thank you, thank you.
So I have a lot of comments on many things you said in the past, but I want to take on this last thing. And I kind of want to tell you that my wife, for example, she runs a nonprofit called Computing for All, and the job, her whole, and it's actually doing very, very well. They got some massive amount of funding from the federal government to, so what is the purpose of that job? The purpose of the job is that, many disciplines are enough with you can get a good job with 2-year education. So, for example, in the state of Washington, there are 32 community colleges, okay? 32. That whole idea of creating community colleges came from people don't want to go to school for 4 years. They don't want to sort of like get these degrees and then, so they thought, but what has happened is, while in many other disciplines, the 2 years has worked, it has not worked in the IT department. And the question is, why? So when you think about AI now, as an example of this, I'm completely in agreement with what Lynn is saying. The kinds of courses you guys teach in academia and things which you call basics and foundationals are useless, honest to goodness useless. I will make a case of like calculus as an example. Calculus, how many of you have ever used calculus in your entire life? What is the purpose of that, like 3-4 months and then 6 months of doing that course? And there are many things, discrete math. What is the purpose of that? In the real world, the world is changing quite seriously. And so you need to think very differently. So the question is exactly right. And this is what she thinks about is how do I get these community colleges who know these systems get jobs by learning some of the AI stuff. So I just pose it as a challenge for you to not think about the basics and the fundamental and things of that nature, because they are no longer the basics or the fundamentals. Things have changed massively. The other point I want to make is that I want to agree with Ashutosh that internally we had a meeting with the SLT, which is the senior leadership team, and they brought in a LinkedIn guy. LinkedIn is part of Microsoft now, but they brought him in and they asked the same question about is GitHub Copilot, which is the engine that helps you write code on GitHub, and it's been very, very popular. It's taken off. Large percentage of the developers use it, and they call it amazing. They said, has it helped for internal purposes? And the answer was exactly the same answer that Ashutosh you heard, which is that the better people become awesome, and the average people just sort of left behind. So you're right in that sense that is, so I'm just sort of corroborating that other thing. And the final thing I want to say is that in Microsoft, for example, and it's not just about Microsoft or any other big company, we had about 50, 60,000 engineers, maybe more, before AI hit, right? And then when AI hit, it was as much a surprise to them as it was to the rest of the world. You guys got to hear it about the same time as all these engineers got. So now a company like Microsoft, which is very big, has a lot of money, and companies like Google or Amazon, you name anybody, have this whole thing about teaching their own engineers AI. So even though in the outside world they go in and talk about all this AI stuff, but they have this big problem of like, how do you re-educate? You can't fire these guys, but what do you do? So then there are lessons to be derived from that when you think about like, okay, well, how is this changing, and is it actually changing the world? And I can't go into the details of how this is happening and how they're doing, but all I can say is that you just purely have to accept this as the new norm. And when you think of this as a new norm, this becomes new fundamental, new basics for the rest of the thing. I'll stop here because, like I said, I have a whole bunch of things to say, but I just want to get these ideas out. If you have any comment on what I said, please do.
Can I agree?
The only thing I would say, Victor, is there still has to be struggle and concentration. I think that's really fundamental to learning, and if AI can be reconciled with that, fine. But from what I've seen up close, the way AI is used is it eliminates struggle and concentration, and I think that leads to poor results. So if there's a way to evolve the way we teach so that AI can focus our attention on things that are more relevant, that's fine. But at the end of the day, you have to learn something. It can't just be, and you have to learn how to learn, and you have to learn how to think through a problem from first principles, and that's the really important skill that I think AI diminishes, at least as it is being applied to today's lessons.
Can I add something after saying that? Thank you.
But before you do, I just want to sort of
Yeah.
we stay in the lane that we are in. The question that was asked that nobody answered
Yeah.
was, she asked a very direct question, which is that, should I be teaching C, C++, or Python or whatever, or should I be actually doing something else with these kids? And none of your answers. I'd love to know what your opinion is about that. Like, programming languages you want to learn, or you want to learn a new way of, or this is a joke, of course, now, but prompt engineering. I mean, I think of it as a joke because a lot of people have made a joke, or something like that. So what direction she's teaching K through 12, and in the UK, for example, they have mandated that every school has to have an AI course. So I think that's how one needs to think about it. Like, what do you teach in the K through 12? What do you teach in schools? Do you need the 4-year thing to teach all kinds of courses that nobody's going to use? That's really the question. So if you would answer that, that would be great.
I'm going to add a few. I'm going to partially answer that question. Especially in K through 12. K through 12 is a little bit different from colleges. In colleges, we choose a major. In K through 12, this notion is actually not there, right? K through 12's job is a little bit different, is to prepare the kids to take almost any job in the world at some point. They could be nurses, doctors, whatever, right? There could be pilots. So K through 12, while we have courses which are later stage courses where we can take computer science, but we can also take health sciences in the same semester, right? We might be doing other things. There's economic sciences, home science, whatever, right? That thing. So K through 12 has to serve pretty much the whole country workforce. And I think there is, in my opinion, the answer might be slightly easier. Whether you teach C++ or prompt engineering is a little bit less of a thing. Part of the thing is that, I assume maybe some of your thing is that students are coming for spending a summer with you, maybe. It's a summer program. And the purpose of that program is actually not teaching, at least in my opinion, because I run many of them at Rice. The purpose is to actually, in my opinion, to get them motivated to actually go to college and to expose them to something interesting and preferably hard, because actually humans like learning hard stuff, fundamentally, in my opinion. Yeah.
That's actually not true at all.
Okay.
Like,
so,
absolutely the absolute wrong thing
and
to sort
that's
of
my
say.
second point. I think we are failing. If we are failing, is because like I have a high schooler, by the way, and I can see the differences. He will tell me openly, the amount of effort kids are putting in now is significantly lower pre-chat GPT, in writing essays, in studying, and how much time they spend on doing something. I think that's a much more significant problem, that we essentially are not able to, we are unable to have them focus for a while, because learning fundamentally is an uncomfortable thing. You have to get out, you have to do uncomfortable things, you have to fail a few times at everything. And that is proven. There's no debate on that. Whether it's called GPT, this or that. There's no debate on it because distractions used to be there pre-GPT also. But now they have reached a point that they can do their homework just too easily and get away with it. And I think that's, I feel, is a bigger hit here, why people are against this idea. That the ability to focus on something.
We're getting philosophical here. I just want you to focus on what should we change in teaching? That's the question. Like, all this is fine, but
That's
and we
the
can
answer.
have
We don't know. We don't know.
We don't know. I think there are people who do know. This may not be the right crowd. So there are, I think, enough people. There is actually studies published just recently about giving kids of different ages GPT support and then asking them to do the same thing a week later. And you find fundamentally very big differences, right? So when you are working with something, it makes you feel you understood the concept. It gives you this false sense of knowledge or understanding, which is actually not there. And that's actually happened with Google already, with search. With search did that to people. People will search anything, feel smart. But actually they don't learn anything most of the time. Because the effort required is so low. Human brain actually only registers things which require effort. And those are the way actual learning happens.
I know I'm supposed to provide answers, but actually I have a question. So I totally agree, the level of concentration the amount of work and endeavor you put into this is great to learning. Could the solution be making education hard enough that even with the state-of-the-art AI tools, it's still a high concentration, high endeavor way to even solve that school question? Could that be?
Creative teaching, yeah. I think so in schools the same thing is happening, by the way. There are kids who really want to learn what I call, people who like learning things. They are using GPT to just get better at it. But then maybe 90% of the kids don't want to do it. Maybe that's all you're telling me, and which may be true. And they're just getting worse at it. So we are about to create a workforce where we will have difficult time. Microsoft will have to pay even more money to hire actual people who know what they're doing, because they went through top colleges only to figure out they actually don't understand logic. And they're about to ship stuff which they don't understand what the logic is. Then you got to hire even super smarter people to debug what the hell they wrote, right? So, and about the planes are about to crash because we don't know what code was actually in there, right?
Yeah.
So all this crap is coming because we basically haven't had actually.
Let me add one more thought, and then I should give up because he's waiting. So here's another thought. This actually came through one of the meetings I was in, and they were talking about this. So what does a CV or resume say now? So for example, for those of you who have not used it, I mean, you all know about ChatGPT, but Microsoft is focused on Copilot, and Microsoft is a very dominant company in the enterprises. What the Copilot does is everything that the ChatGPT does, but it also brings in all the enterprise knowledge that ChatGPT doesn't have. So all this context and documentation and things of that you can actually put, and then it can go through your documents. Anyway, it's very powerful, and I use it quite regularly, and people in Microsoft use it quite regularly. The question that came up with this is that you go future for 5 years, and these co-pilots are being built for all the enterprise. For example, J&J, which is in the business of pharma, they have their own co-pilot, let's say. And some other company which is doing something more specialized, aerospace engineering, they have their own co-pilot. Now, the question is, when you study this and you use Copilot, your dependence on Copilot becomes very high. But when you leave the company, you can't take the Copilot with you. It stays with the company. And so when you're trying to hire somebody and he says, well, I know this, but that has no meaning to you anymore, because he doesn't know whether how much you know that you did versus what the Copilot did and what you're going to do in the next company as well. And that's a real problem too, because the CVs don't tell you that. And then either the interview will also not train. The training of the people is not adequate in terms of like you believing what is being said, is that person is capable of it or not. And this is not a made up problem. This is an actual very real problem that at least I know in Microsoft, because again, going back to LinkedIn, these guys think about this on a day-to-day basis. Is how are you going to create an education system that can live with this new AI world and yet be useful in these kind of ways where you're trying to hire people as well. So I don't know if you have any thoughts on that, but I will pass it on.
I apologize for interrupting. We are approaching the end, so we can have more discussions offline regarding the education topic. So please, the last question. We want to focus on IoT.
This is also on the education topic.
Okay, so we don't want it to be like IoT Education Day, right? We want to focus on IoT. So I will leave.
I can bring it after.
Yeah, please. Yeah, you guys can discuss more after. So I think the time is up. So I would like to thank all the speakers and panelists. I do have one last question that has not been covered. I want to leave it for the next year's IoT Day, which is how do you think the IoT system research would play a role in realizing the world model and further the AGI? So I think probably that's one of the ultimate goals of the AI research, all related. My daughter was asking me whether we are able to realize the virtual world in Matrix, the movie Matrix. My answer is yes, probably in the next, I don't know how many years. So next year, when we are coming back for the IoT Day, I hope we are getting closer. So next year, probably we will have, like all of you, hopefully, to come here again, and we will see, we will have the chance to discuss further, like whether how much we are getting closer to the world model and the AGI. So again, I would like to thank all the panelists, thank all the audience for attending the IoT Day. Hope you enjoyed the program. Okay, thank you all.